Welcome to the Single-Engine High-Wing Electrical System Video Series, Volume 3. The content of this presentation is for reference only and does not contain instructions for continued airworthiness. The approved procedures, in their entirety, are set out in approved technical publications. Abnormal operation in Module 3 here covers system malfunctions and how they are indicated in the cockpit. In our first scenario, the flight crew has observed a high volts CAS message. The POH tells the crew to turn off the master alternator switch and reduce electrical load, as the systems will now be running on the main ship's battery and, if necessary, the standby battery. The question becomes, what caused this CAS message to appear? Let's look at the triggers in the specifications for some clues. Here we see that our high volts is a red color CAS message, and it is triggered when the analog sensor is seeing a voltage greater than 32.0 volts. The sense for this CAS message is coming from the warn circuit breaker and is being fed to a GEA input. So it's the bus bar behind that circuit breaker that is actually feeding this information to the GEA. There is a secondary trigger for the high volts CAS message, and again, note 1 tells us that about the 32 volt threshold, but we're looking at a different sense point. The essential bus high volts indication is triggered when the GEA senses high voltage at the NAV1 ENG circuit breaker, engine monitor circuit breaker. Two different inputs to the GEA to trigger a single CAS message may be confusing, but a suspected trigger error can be verified by looking in config mode at the GEA status page. In order for this CAS message to appear in an actual overvolt situation, we really need two failures to occur. First, the voltage regulator in the ACU would not be correctly regulating the alternator field voltage. Second, the ACU overvolt protection circuit should shut down the alternator at 32 volts before this CAS message ever appears. Before condemning an ACU, the specifications of the ACU should be understood, as well as the differences between points of regulation, monitoring, and indicating. As we look at the specifications for our AC 2101 ACU, we see it's factory set non-adjustable 28.5 volts for the life of the ACU, and the point of regulation is the primary bus. We also look at the overvoltage trip point. It's set at 31.75 plus or minus a little over the range of the unit, and its sense point is the primary bus. So while both of these items say that we're looking at the primary bus, we're actually looking at two different physical locations. If we look at a couple diagrams of the electrical system, we can better understand differences between our point of regulation, monitoring, and the sense points for CAS message. So as we look at these diagrams, we've got one from the POH on the left and an ACU schematic on the right, and we'll highlight some of these wires so we can kind of understand where we're going with some of these things. So as we see the red highlighted wire there in both diagrams, that's the same wire. That is the power for the ACU, and that is coming from the alternator field circuit breaker. The output from the ACU to regulate the alternator is the blue wire, and that is exciting the field in the alternator. The output from the alternator itself, it's a white wire on the airplane, so that's kind of hard to draw in the picture, but that's going to be our pink wire drawn down here and the pink wire highlighted across here. That is output from the alternator going into the ACU and then into the aircraft system. So the output from the alternator is going to the battery terminal, goes through the ACU bus bar, and all drawn in pink here. And then our overvoltage sense picks off of the main bus at the battery relay. So that's a little bit weird, but is a different location, and that's our orange wire shown in both of these diagrams coming from the battery relay. So our high volts annunciation scenario It's possible that a wiring fault is overexciting the field, causing an overvoltage outside of ACU regulation. High resistance due to corrosion or a loose connection at the orange sense wire could prevent the overvoltage circuit from tripping while the alternator is overexcited. While it may be likely that an overvoltage condition is caused by a faulty ACU, that may not be the only possibility here. Another annunciation or CAS message a flight crew may see is low volts. If we take a peek at note 2 on our specifications, we see that low volts is triggered by the ACU low volt signal. Again, as we go back to our AC 2101 specifications, we have a low volt sense. It's set at 24.5 volts, non-adjustable. And again, we're stating that the sensing point is the primary bus, but we're not telling us exactly where. Looking at the wiring diagrams again, we see the orange sense wire that was connected to the overvoltage circuit here also has a leg that comes down into the low volts circuit. When the low voltage circuit senses a voltage drop below the threshold, it will ground the yellow wire, which triggers either the annunciator light on our NAV1, NAV2 airplanes, or triggers the CAS message on our NAV3 airplanes. One scenario that we often see in these aircraft is we will have a complaint of a low voltage annunciation while we see 28.5 volts on the aircraft display. How can we see 28.5 volts but have the annunciation that's triggered at 24.5? Well, this is because our little orange wire coming into the top of our battery contactor here is seeing a low voltage condition for some reason. Oftentimes, it's just a condition like a loose nut or a little bit of corrosion or a bad crimp on the wire. Something is driving up resistance. So this wire may only be seeing 23 volts while we've got 28.5 volts flowing through the rest of the system. This could also be a bent pin at the GEA. Pin number 60 is the discrete input. If it finds a ground, the CAS message comes on. It doesn't really care why. It just knows that that pin is grounded, and it's going to give us a CAS message. Finishing up the ACU specs, we see that there are a couple of non-enunciated protection modes. The only indication to the pilot is a tripped circuit breaker, but we don't know why. This often leads to multiple ACU, alternator, circuit breaker replacements when the root cause could be just a simple wiring fault. Red X's are another common complaint in the voltage indication system, and those are not well defined in our maintenance documents, but the red X trigger for our voltage indication is either going to be an exceedance above about 50 volts or below negative 5 volts. So that's often a polarity issue where something is connected wrong that's going to give us that red X indication on volts. Moving on to current indications, main battery current indication is provided by a millivolt signal measured from a Hall effect sensor or a current shunt, our calibrated resistor in the system. The display components turn yellow to let us know that we're in a discharge mode, but there is no CAS message that's actually related to the amperage indication system on the aircraft. The red X's are displayed when the signal is beyond plus or minus 92 millivolts or an indication of negative 110 or positive 110. Oftentimes, trouble with this system is just a simple resistance issue where we need to clean up the contacts. When it's a millivolt system, it doesn't take much to throw it off. A little bit of resistance here or there can make a big difference in what we see indicated on the display. Sometimes when we see a discharge, we'll have to do some more action here. We may see a discharge in the system where we know that we are charging the battery. If we see 28.5 volts, we know we have to be charging a 24-volt battery. In cases like this, it's likely that we need to perform a high side current monitor calibration, and we're going to do that procedure per the G1000 line maintenance manual. Now, this is a procedure that is only available on the legacy G1000 systems. Some of the very early NXI systems that still use the original GEA 71s can do this. If it's a newer system with a GEA 71 Bravo, the high side current monitor calibration is no longer available because the circuitry in the 71 Bravo is that much better that we don't have to do this procedure anymore. The final CAS message we will discuss is the standby battery enunciation. The POH does not have a checklist or procedure if this CAS message appears. It is a yellow CAS message, so no immediate action is required like if it were a red CAS message, but a complete loss of avionics could be impending, so it's telling us that it's time to come up with a plan. It is discussed a little in Section 7 of the POH, but the only real guidance given here is that if this CAS message appears, it's likely the alternator isn't keeping up, the main battery isn't getting the job done, and so now the standby battery is being discharged to keep the essential avionics up and going. If this truly is the case, terminating the flight as soon as practicable would be the right thing to do. However, this discharge enunciation is based on an ammeter reading, and just like the main ship's battery, the first question when troubleshooting an ammeter squawk needs to be what the bus volts indication shows. If we've got 28 and change on the essential bus, it's not really possible to be discharging a 24-volt battery, so we know it's an indication problem, not a charging system issue if this is the case. Looking at our specifications for the CAS message, we see that we need to be showing a half of an amp discharge for longer than 10 seconds before this message appears. We are calculating the amperage by measuring the voltage drop across two parallel resistors on the standby battery PCB. This unit is found on the forward side of the pilot's outboard switch panel inside this little enclosure. We can do the math here and find that our half amp discharge is indicated by a quarter of a millivolt drop in the indicating circuit. With that level of sensitivity in the system, most faults can be tracked back to poor connections. So cleaning up the connections, applying a little contact enhancer, that often resolves these nuisance indications. Just like our main ammeter indication, our legacy GEA 71s have a high side current monitor calibration procedure in the Garmin line maintenance manual to recalibrate the ammeter circuits. If we are confident in our connections and we've performed the high side current monitor calibration but still have a false discharge indication, it may be time to send the GEA out for repair or recalibration. If our squawk is for an inoperative ammeter display, we see our amperage indication will fail, or red X here, if we have a charge or discharge rate of greater than 30 amps. That's an input to the GEA of 15 millivolts or more. Since a broken wire or open circuit would result in a zero voltage drop measurement, a red X indication is more likely to be caused by a chafed wire or improper connection feeding stray voltage into the ammeter circuit. This concludes our look at abnormal operations and indications. Our next video will look at scheduled and unscheduled maintenance checks performed on the aircraft electrical system. Thanks for joining us.